Okay, hi guys. This is your daily video for Friday, April 24th. On the 23rd, on Thursday, we talked about transformations coming from A, and today we're going to just talk about transformations coming from C and D. So similar to yesterday, actually way easier than yesterday. Um, we're just going to throw in the other elements here. So, this is going to be another two-part video, so right now I'm just going to talk through the notes, and then I'm going to do 3 examples on a separate video up on the whiteboard. For these problems, we're going to disregard A just for right now. We're going to put everything together next week, but just for right now, I want you only to focus on C and D. We did A yesterday. C and D we're going to focus on today, and then next week, like I said, we'll put it all together. Okay. So, quick reminders, here's your standard form. You've seen this a few times now, so hopefully is like burned into your brain a little bit here. Again, here our C value is the one on the inside, our D value is on the outside, and then this one over here, just remember that C and D are allowed to equal 0. So if there's nothing in here or nothing out here, if there's nothing in the C or D spot, those ones are allowed to equal 0. A is the one that has the invisible 1 here. C and D, those are allowed to be 0. If there's nothing there, they're just 0. Okay. So we're going to talk about the jobs C and D have. So if you remember, A could flip, stretch, shrink. C has its own thing going on, and then D has its own thing going on. So C shifts our graph left or right, and then D shifts our graph up or down. And these are really super easy to figure out, okay? So here's what C does. This is what it looks like on the actual graph. So if you notice here, our red dotted line, this is our parent function, okay? So our red here, this is our parent. And then we have this blue function over here, and then we have a black function over here. So this is 3 separate graphs for 3 separate equations. So you have the blue, the red, and the black. Okay, the red is like the original, right? That's our parent. Okay. The blue, if you notice, has a shift to the left. Okay, so from the parent function, we move to the left. Nothing else changed. The shape stayed the same. It's still pointing to the right. It's still going up. Nothing else happened here. We just went from here in the middle, 0, and then we just went to the left, 3. Okay, so the blue function is a shift to the left. The black function over here on the right, this one is a shift to the right. So from the middle, from our parent function, we shifted over to the right. So this is what C does to the graph. It moves it either to the left or to the right. And just for clarification, you can't have a shift left and right at the same time. So we're either doing one or the other here. Like we're either moving to the left or we're moving to the right, or we're not moving at all. We're either in the middle, we've moved to the left, or we move to the right. We can't move left and right at the same time. So remember our keyword here for C was counterintuitive, meaning this is opposite what you expect. So this is the only thing that trips people up for transformations from C. C is opposite. So our rules, if C is positive, we're shifting to the left. This is not normal, right? Normally, our positive numbers go to the right. If you think about a graph, looking back here, right, positive numbers are all to the right here. Normally, positive is on the right and negative is on the left, but this is opposite, okay? So C is counterintuitive. It's opposite what you think. So if C is positive, we're actually shifting to the left, and if C is negative, we're shifting to the right. Okay, so that's the big thing you have to look out for here. If it's positive, we're going to the left. If it's negative, we're going to the right. This is opposite what you think. Okay, and then if C is 0, it just means we're not moving to the left or the right. We're just staying right in the middle. Okay, so if C is positive, we're going left. If C is negative, we're going right. And if C is 0, we're not going either direction. We're staying right in the middle. Okay. D, similarly, doesn't really change the shape of our graph at all. It just changes the position. So here are our 3 functions. Our red in the middle here, this dotted line, this is our parent, this is the original, okay? The black function up here is a shift up, Okay, so if you notice, we started at 0, we shifted up 3 units here. So this is a shift up, okay? And then here, this is a shift down. Again, nothing changes on the graph, right? These are all the exact same shape, just the position has changed. So A is the only one that can actually change the shape of the graph. C and D just change the position, okay? So moving up or down, left or right, but it doesn't actually change the shape of the graph at all. So for D, this is the easiest one. D, the keyword here was deductive. This just means it's exactly what you would expect. Where C is opposite, D is just exactly what you think. If D is positive, it's going up. If D is negative, it's going down. And then again here, if D is 0, it's not going up or down, it's just staying right in the middle here, okay? So this is super easy, right? A positive D value is moving up, a negative D value is moving down. So this is the easiest one out of all of them. Okay? Positive going up, negative going down. If there's nothing there, you're just not moving up or down at all. Okay? So just some quick clarification things here. C and D are a lot easier than A. You don't have to check the absolute value. It's not greater than, less than anything. It's just, is it positive or negative? Is it going left or right? Is it going up or down? So those are pretty straightforward. Just remember that C is opposite. Normally positive is right and negative is left, but C is backwards on that. So just pay attention to C very, very carefully. And then just remember that C and D are allowed to be 0, and if they are 0, then there's just no shift at all, okay? Which is totally fine. It's a totally acceptable and reasonable answer for some of our functions, okay? I did make a foldable, so this is completely optional. You don't have to do this, but if we were in class, we would do this. I just wanted to give you the option here. So I made a foldable for A, C, and D, similar to some of our other ones that we've created. So if you want to make this, you can. Here's what the outside looks like. So I just did in half, hot dog style, and then I did in thirds, and I just cut the little flaps here. And then this is what I have on the inside. So I have all of the notes on the top, and then I just have examples on the bottom. So A is for alter, C is for counterintuitive, D is for deductive, and then it just has all of the rules in here, little extra notes, and then 3 examples of each one all the way worked out. So if you would like to make one of those, you absolutely can, if you think that would help you on this stuff. Okay, that's all I have for you for notes on C and D. I also posted a part 2, which is the example portion of this. So I'll actually work out some of these on the whiteboard. Okay, so go ahead, watch the daily video part 2, and then you are off to Google Classroom for your assignment. Great job, guys.